this. So it turns out that integration is, you have to learn a lot of techniques. First thing you learn is just the basic antiderivatives, the power rule, and stuff like that. Then you have to learn a substitution rule that's called U-substitution. Now, I'm not going to go through much of the terminology from this. I'm going to start with examples, then I'll go back with talking about what this theorem is saying. But the idea is going to be you can do change of variables to substitute in your integrals. I'm going to go ahead and have you go to page 2, and we're going to just work out some examples, then I'll talk a little bit more of the theory on here. So the idea is going to be, if you look at this particular example like here. Now, first of all, that is an indefinite integral. Okay, does everybody understand what I mean? Indefinite integral does not have a definite answer. It doesn't have limits of integration, so you're always going to have that plus c. Okay, and that's important. You have to train yourself. If it's an indefinite integral, like it or not, you got to put that plus c, because it's wrong if you don't put that plus c. Yes?
If you don't give us an integral, is there ever a time that we have to try to find c without the integral?
I'm sorry?
Do you need the integral in order to find c?
Yeah, if you don't have the limits of integration, you're going to have a plus c, period. Okay? If you have the limits of integration, like if this was 1 to 2, then you can go get a definitive answer. Because that's why we call it a definite integral. It gives a definite value for that area. Indefinite can be, it's really an antiderivative is what it is. And then plus c, it can always be off by a constant. That's the idea. Okay, so let's take a look at this integral right here. So if you don't know the U-substitution rule, you would be forced to FOIL this thing out 99 times and integrate like that, term by term like that. So we have a methodology that we can use, so listen carefully because you have to wrap your head around what you let u equal to. So the idea is when you're making a change of variables, one thing that you always want to do is whatever you pick for u, this is key, the derivative of u should be the remaining expression in the integral or off by a constant. So the only way I can do this is just kind of get you going. I'm going to show you what you would set u equal to in this problem. Okay, so what I'm going to do is we're going to let u be equal to x squared minus 1 like this. Okay? Now, I need to point something on here, so I need to stand up and show that to you. When I say this statement right here, here's what I'm saying. Okay, I want you to just imagine that that becomes u. Would you be able to do the integral u to the 99?
Yeah.
Absolutely. What is the integral of u to 99? It's u to the 100 over 100, right? Okay? Now, if you do the derivative of this thing right here, what's the derivative of x squared minus 1?
2x.
2x. See, it's the rest of what's there. That's important. That's how you know that you're setting your u correct. So, and you also have to have that dx there. So if you block that whole thing off, that du is going to be 2x. And du means take the derivative of that function that you set u equal to. So what you do then is you go ahead and do this derivative, which is 2x, and do not forget to put that notation dx. You got to have that. Okay? So what we have then is that thing right there is going to become u. Okay, I'm going to highlight this in blue. Sometimes that helps students a little bit. What I highlighted in blue is going to become du. You got to make sure when you do this change of variables that everything is accounted for. That's important. So what we do now is we get what we call a u integral. So it just goes like this. What I highlighted in yellow is now going to be u, and that's to the 99th power. Okay, what I've left over in blue, that's going to be what du is. So that's how you got to do that. Now these problems are designed so that they work this way. And then we're going to kind of start with the simpler case, and then we'll go to one other case. We just look at a few things in this class. Okay, so what's the integral of u to the 99th? U to the 100 over 100 plus c. It's an indefinite integral, so you have to have that. Now, that's not the answer to the problem. What you have to also do is you have to plug back in u, so that thing has to go back in, and then that gives the final answer to the problem. So what you would have is change the u back to x squared minus 1. That's still to the 100th power over 100 plus c like that. So that is the final answer of the problem. Okay, did that make any sense? Sometimes it takes students a little time to wrap their head around this, so we'll kind of get the basic case going here first. Now, what I recommend that you do, usually on the final exam, we usually put like one U-substitution. It's the end of the semester. Students usually don't have a lot of time to perfect this, but you want to try.
What happens to that 2x?
That was absorbed in the substitution. See, that's the point on this is we turned it into this integral. See, u was what I highlighted in yellow. The 2x dx became du, so you end up with an integral you can do. That 2x dx is absorbed in the substitution. It's not something you're integrating. It's a part of the substitution. Okay? All right, now let's check the answer. Now, I recommend when you're doing that final, check the answer on these integrals. So let's take the derivative of this function. Let's take the derivative of our answer and see if it gives us where we started. Okay, so let's do that. And this is just basically a chain rule derivative. So basically what you could do is, you know, this constant right here, you can just write that down. So that is 1 over 100 is what that is. And then when you do this, do the chain rule. So bring down the 100, that would be 100 x to the second minus 1 to the 99th power. And then you got to do the derivative of what's inside, which is 2x. Okay, that's basic chain rule. Now let's see what happens. The hundreds cancel out. So what you're left with is 2x times x squared minus 1 to the 99th. Is that what we integrated? I think it is. So see, we're right. That's how you can tell you're right. You take the derivative of your answer and see. You got it. When you're doing U-substitution, everything has to be accounted for. Okay, that's the big deal. All right, does that make any sense? Okay. All right, let's look at this next one then. Okay. Now, what will happen on this, now I'm going to do something wrong on purpose. I always feel like when I teach it, I got to do that a couple of times. Let's just say that we let u be x. Okay, if I did that, well then that thing would become u. All right, now here's the reason that's wrong. Okay, and you're going to know when you're wrong on this. The idea is, what is the derivative of x? 1. Is that what's left over? No, bad idea. Okay, see, that's what you get into. So you have to think about what is the correct thing to do. Now see, here's what I see. I see an e, and that pretty well nails down what I'm going to do on this. Okay, what if we ended up with the integral of e to the u? Wouldn't you like that integral? Yeah, that's e to the u, right? So the best thing to do on this one is let u be that exponent, okay? Because you want to turn this into e to the u integral. So let's just let u be x squared, okay? All right, so we got that absorbed. We got the function. We got e to the u now. Okay, now, what is the derivative of x squared?
2x.
2x, okay? Now, notice that's not quite what's left over, but we can handle that. So this becomes 2x, and don't forget to put that dx there, okay? So the idea with here is we're almost there. We're close, okay? Now we've got e to the u, but we got x dx. We're off by a constant. Now this is an equation, so I can divide both sides by 2 here. Then I've got x dx. Then I can substitute in. So if you're off by a constant, you can always handle that. So what you need to do here is just take this and multiply both sides by a half, or divide by 2, it doesn't matter. So what you get is you end up getting 1/2 du is equal to x dx like that, okay? So here's how this goes now. Everything is now accounted for, see? Okay, this thing right here is going to become e to the u, right? Because that's what u is, it's x squared. What I've got highlighted in blue, that blue part, what that's going to be is this, 1/2 du. So now you're ready to put together your integral. Everything's accounted for, okay? Does that make any sense? Sometimes it just kind of goes right through students' head the first time. Okay, we'll get it though. So here's what we got. You have the integral of e to the u. Okay, that's what u was. U is x squared. Okay, the x dx, what is x dx equal to? 1/2 du. As long as everything's accounted for, then you've got a valid U substitution. And you always want to end up with an integral that's easy, something you can do. So see, this one, what you do is you just bring out the half. So you'd have 1/2 integral e to the u du. All right, what's the answer to that integral? 1/2 e to the u plus c. All right. Now, there's one other thing you must remember to do. You always got to do this. Whatever u is, you got to go back and plug it in because your answer's got to have x in it. Okay, that's the original variable. So the final answer is going to be 1/2 e to the x squared plus c. So that is your antiderivative on that one. Okay, so you're off by a constant. You have to kind of massage that a little bit. It's a lot of times what mathematicians say. Okay, deal with the constant so everything matches up. Okay. All right, let's do a derivative on this then, and let's just double check and make sure that we're correct. This is an easy enough derivative. You can just do it in your head. So if you do that, you write down the constant. How do you do a derivative of e to the x squared? What is it? It's itself and then what? Derivative of exponent, which is 2x. Well, notice the 2's cross out. You're back to x e to the x squared. So see, that matches what we had. So check and make sure it's right. Okay, the thing that sometimes students don't understand on this problem when they're learning this is that step where I multiplied by a half. The reason I did that is that x dx, we needed to make that x dx, and it turned out to be 2x dx. So we just take that one extra step to make it match. Okay, does that make any sense? Okay, it'll get better, okay? Hopefully. Okay, so I'm going to let you guys do a couple of these in class. Now, let's just kind of talk through what you think you would do on the first problem here. Now, see, what I see is I see a cosine. Okay, if you ended up with a cosine u integral, is that something you could do?
Yes.
Yeah, what is it? Sine u, okay? So what do you suggest we use for u? Okay, let's do that, okay? Now I'm going to let you guys take it from there, and I'll let you try number 4 yourself too. Tried to just give you the basic ones and give you a little time to see if you can absorb in your mind the more basic ones, okay? So go ahead and work on that for a few minutes and see what we get. Let's see, I'm going to go ahead and get through 3. If you're still working on 4, you can do that. Let's kind of see if we got the idea. Okay, so u is going to be what I highlighted in yellow. I'm hoping when I get du, I get what I highlighted in blue. Okay, so du is 8x dx. Okay, see what it is it's substitution. So that 8x dx becomes du. All right, so what you end up with is you end up with the integral of cosine u du. Tell me if you understand that. I never can tell when I teach this. Okay, it's substitution.
How can we make it a du or the u?
What's that?
How can we put that in? How can we put cosine in for u or du?
Okay, because I want to end up with a cosine integral. Cosine is a function. Okay, if you see a cosine in your integral, it's highly likely that you're going to end up with a cosine u integral. Just like if you had an e in your integral. It's highly likely you'll have an e to the u integral. Okay, that you don't change the cosine, you can change the argument of the cosine to u. That's the idea. Okay? All right, what is the integral of the cosine? Sine u plus c. What else do you do to finish up the problem? Plug u back in. Okay, then you got it. Okay, so the final answer of this problem would be sine of 4x squared plus 3 plus c. That's it. And you should be able to just do a real quick check on this. Just do the derivative. So if you did the derivative for checking, you would get the derivative of sine is cosine. And then the derivative of what's inside is 8x. Like that. See, we're back to the beginning. See? All right. Okay, how about the next one? What do you think u should be set to? 3x squared plus x. Okay? Because see, you want to end up with a square root of u. Okay, if I had you do the integral of square root of u, you could do it, right? That's power rule stuff. The other thing is, notice that when you get du, tell me what du is.
6x plus 1.
6x plus 1, exactly. Times dx. Don't forget to do that. So see, you've got everything absorbed. The u is under the radical, and then the part I've got in blue, that's going to be du. So what you end up with is the integral of square root of u du. Okay, you want the square root there because that's the function that you're integrating, see? Okay, does that make sense? That's kind of why you're asking the question about the cosine. The cosine's a function, that's a part of what you're integrating, okay? All right, now how do you integrate this? You do the integral of u to the 1/2 du, so that's a power rule, right? So when you do that, you would have u to the 1/2 plus 1 over the result, okay, which is 3/2, and you can always kind of do that in your head if you want to. So that would really give 2/3 u to the 3/2 plus c. Okay, then what do you do to finish it up?
Yes.
U back in. Okay, do that. And you can leave the answer there. You don't have to change it back to a radical. So it's 2/3 times 3x squared plus x, all to the 3/2 power plus c. So that's your answer to your problem. Okay, take the derivative, check it, it'll work beautifully.
How do we go to 3/2 and then the 2/3 in front of the u?
Why the 2/3? Okay, look what I did on this integral. I'm doing the integral of u to the 1/2, right? Power rule. Add 1 to the exponent. The result of that's 3/2. When you divide by 3/2, that's the same as multiplying by 2/3. Okay, like that. Okay, that's fine. You'll get it. I mean, this is new stuff to you, so it's fundamental stuff. Once you practice this, it'll be second nature to you. Okay, there's not a single student I have in Calc 2 that doesn't have that down by now, so you'll get it. Okay, so what do you guys think of that so far? Okay, that's kind of, those two are not, I don't consider those to be the harder U-substitutions because du matched perfectly the rest of the expression in the integral. Now we're going to focus probably the rest of the time on the ones that are off by a constant. So one of the things you've got to kind of look at on these problems is think about, okay, what if we ended up with a square root of u? I see that I have a square root. What if you ended up with this? Could you handle that integral? Yeah, okay, what would you do? You would just say integral of 1 over u to the 1/2, integral of u to the -1/2. And then you'd use the power rule, okay? So let's try this and see what happens. So I'm going to try to let that be u, and sometimes you're going to pick the wrong thing, and you'll know that. So that's 1 minus 4x to the 3rd. Okay, tell me what du is. -12 x to the 2nd dx, right? Okay. Now, does that match what I highlighted in blue? Not perfectly, but we can make it happen, okay? So here's kind of the idea on this that you could do. Well, there's a couple of things you could have done. One thing you could do at the beginning of this problem is you could move that 2 out of there, okay? Now I'm going to start it that way, so let's just say, okay, first step, let's just move that out. So now we're really focused on this integral right here. Okay, you got a constant, you can move it out. Okay, so we got u is what I'm highlighting in yellow. Now I'm wanting the du to be x squared dx. So it's actually pretty simple on this, is the way we change -2 to x squared dx is we just do this. We just divide both sides by -12, which really means that we're just doing that. Okay, then what we would have is we would have -1/12 du is equal to x squared dx. Okay, see the thing is that you gotta focus on when you encounter this is it's a good idea to take the 2 out so that you're focusing on that now. So I was just thinking in my mind, okay, I see x squared dx, I need to make that go away, right? Now that matches that perfectly. So your integral is going to go like this. You're going to have a 2 there, because you took it out. That's going to be u. What's x squared dx going to become? This, okay? Everything's handled. Everything is accounted for now. So now we're ready to build our integral then, see? Okay? So let's do that. See if this makes any sense to you. So the 2 comes down. That came out of the original problem. Okay? U is what I got highlighted in yellow, so that's square root of u. X squared dx is this thing right there. Okay, so that just becomes negative 1/12 du. Everything's accounted for, and we're down to a point where we have an integral we can do, see. Okay, so what could you do with the negative 1/12? That's a constant, so what can you do?
Pull it out.
Pull it out. Okay, so what you're going to have is you're going to have 2 times negative 1/12 times the integral of du over, and I'm going to write that as u to the 1/2, like that. Now this is an integral you can handle. It's a basic antiderivative. That reduces to negative 1/6. You can write this integral as u to the negative 1/2 times du like that. Okay, now you can do the power rule to do that. Okay, so if we do that, we have negative 1/6. Add 1 to the exponent, so that's negative 1/2 plus 1/2. The result of that's a half, so we divide by a half, like that. That's power rule. So what I have is negative 1/6. If I divide by a half, I'm multiplying by 2. Then I've got u to the 1/2 plus c. Okay? This will reduce down to 1/3, so it's negative 1/3. And then you want to plug back in the u. The u is this thing that I have in yellow. So that goes back in there to give the final answer. So that one, plug back in the u, 1 minus 4x to the third, plus c, that is the answer to your integral. Okay, how does that one look? Not too bad, okay. The thing is, the du part is the thing you have to work with. You gotta figure out the correct thing to set u b to, and then the du, sometimes you have to mess with that to get it to match up. Okay, tell me, I don't know. Okay, yes.
So can we fairly consistently say that u is always going to be equal to the argument of the function?
Yeah, whatever you're integrating in general. Okay, so like that's what I was trying to say. If you had a sine in your integral, you probably want to end up with a sine of u.
Right.
If you had an e in your integral, you probably want an e to the u, like that.
Right. And
Yeah,
then,
if the square root, you probably want it to be the argument under the radical.
and then du is going to be
Either
everything that isn't the function or its argument.
it's going to be the rest of what's in that integral.
Minus the function, though, right?
Okay, and then you might be off by a constant. Okay, that's kind of what happened here, is we wanted the du to be x squared dx, but it turned out to be a constant times x squared dx. If you have that, you can handle it. You always can. Okay? Yeah, you got something? You okay? All right? Okay, let's push on. We'll keep doing some of these. I'm going to do one of these and let you try to do some of these in class. So let's see. All right, you tell me, number 2, what do you think would be a good thing to set u equal to? 10x minus 3. Okay, let's think about if that's a good idea. If this thing was u, then you would end up with an integral of 1 over u. Can you handle that integral okay? I hope so. What is the integral of 1 over u? It's natural logarithm, right? Okay, so now what you're hoping is, when you get du, you're hoping du is 1 dx. But if it's off by a constant, we can manage it, okay? So what is the derivative of 10x minus 3? 10, okay? And then we still have dx. You don't forget to do that. So we're close, okay? What we want is we want that to be a dx. We don't want it to be 10 dx. So what do? Divide by 10, exactly. Like that, okay? So what you get is you get 1/10 times du is equal to dx. Okay, now everything is accounted for in this integral. So the idea is this thing right here is u. Okay, this thing right here, the dx, is what? 1/10 du. Okay, right there. Now it's all accounted for.
Why did we choose 10 for du?
Well, we needed to have, I didn't choose du, I found du. See, what du is it means we're just doing the derivative of what u was. That derivative's 10. That's where it came from. So you choose u, you find du. That's the idea. Okay, let's put the integral together then, okay? Tell me what the 1 dx becomes. 1/10 du, right? Okay, and then the u is the denominator, so that's your u integral. That's your change of variables, like that. All right, what can you do with 1/10? Bring it out, it's constant, bring it out. So that gives 1/10. Then you got the integral, and you can write that as 1 over u du. So that's 1/10. Okay, what's the antiderivative of 1 over u? ln u plus c. Make sure you have the absolute value around the u. And then the last step's always the same. Whatever u is, plug it back in, okay? Because you want your answer to have nothing but x in it. So that's 1/10 ln 10x minus 3 plus c. So that is the final official answer to that indefinite integral. You can check it by doing a derivative. You can probably do that in your head, okay? All right, so let's see. I'm going to let you guys try this one, and we'll kind of talk about what you think we should let u be equal to. What do you think?
X to the 4th plus 16.
Okay, let's try it. Okay, x to the 4th plus 16. Now, remember, if that's your u, then you're hoping that you would just end up with an integral of u to the 6th. You could do that, right? Okay, the other thing is you're hoping that when you differentiate that, when you get du, it would give you x to the 3rd dx, or it would just be off by a constant. You guys take it from there. I'll give you a couple minutes to see if you can finish it up. The only way to learn how to do this stuff, of course, is to just do it. And once you get the hang of it, like I say, my Calc 2 students, they know how to do U-sub fine. Occasionally, they struggle a little bit with trying to figure out what you set for U, and sometimes you have to trial and error that a little bit. But I think what you said, Stephen, was pretty good. The argument of what you can integrate is what you typically are going to set U equal to, right? If it's a cosine or if it's an E or whatever. That's a good way to look at it. And what you're doing here is kind of a good example of what you'll see on the final. Like I said, it's usually 1 or 2 U-sub. Either a straightforward one or one kind of like you're doing here right now, where it's off by a constant. Now let's see if we got if we're handling the du part right here. Okay, so tell me what du is.
I thought it was 4x cubed.
4x to the 3rd, don't forget to put your dx there. Okay, all right. Now what are you trying to change this into? You're trying to change this into x cubed dx. How do you make that happen? Divide by 4, see? Like that, that's the idea. So what you end up with then is you end up with 1/4 du equals x cubed dx. Okay, now you've got everything accounted for. So the idea is that thing right there is going to be u, like that. Okay, then the part that I've got highlighted in blue here, see, that's going to become 1/4 du. Okay, everything's accounted for. So tell me what your u integral is. What do you have? U to the 6 times what? X cubed dx is 1/4 du. Okay, like that. That's what you should have done. All right?
I don't multiply because in the original it's multiplied.
Now, see, the thing you got to understand is when we did that du, you got to make it match what I have highlighted in blue. So it goes like this. You know du is 4x cubed dx, right? You want it to say x cubed dx. This is an equation. So what I do is I divide both sides by 4 so that I get x cubed dx. Now what is that? It's 1/4 du. You're making it match. That's the point. That's why I divided by 4, is so I can make it match. All right? Okay, now what do you do with the 1/4? You bring it out, so that's going to be 1/4 integral u to the 6th du, like that. All right, now you should be able to handle it with ease. So that is going to be 1/4 u to the 7th over 7 plus c, that's power rule. And then the last thing that you got to remember to do is whatever u is, plug it back in. Okay, so the final answer you should have got is 1 over 28. 4 times 7 is 28. And then u is x to the 4th plus 16, all to the 7th plus c. That's it. Okay, how many people got it?
If you put the
2, 3.
parentheses and on top of
Okay,
that,
well, try to let you wrap your head around that in class a little bit because you got to practice that a little bit. Okay. All right, so any questions about that? Okay, now I'm going to show you a couple other things that do happen. The ones that I'm going to do on this next page, you know, generally since we're at the end of the semester, we don't do this on the final. I like to show this. These are a little bit more subtle in the way that you do your substitution. So what I'm going to do on this one is we're going to start this one off. We're going to go ahead and let u be x minus 2. This has just got one other little twist that I'm going to show you on the problem right here. So we're going to do that, and what are we hoping that du is? You're hoping it's x dx. You hope, but it isn't. Okay, what is the derivative of x minus 2? 1. Okay, so that would be 1 times dx. Well, we were hoping it was an x dx. Okay, well, here's what you got to do on this, and watch this very carefully. You have to substitute in a little bit different way. Okay, this right here is an equation. You could take this equation and you could solve it for x. What I'm going to do is I'm going to move that 2 over there to get u plus 2 is equal to x. Okay, now what I'm going to do is I'm going to kind of try to highlight and show you what I'm substituting in for. So let me draw this integral a little bit bigger so see if you can follow how I substitute this. Okay. So here's how it goes. All right, x minus 2, what is x minus 2? That's u, right? That's what we set u equal to, agreed? That's what that says. Okay, what is dx? du. So that thing right there is du. So we got that totally accounted for. What is x? X is u plus 2. Okay, so I can actually replace that x right there with u plus 2. Everything is accounted for. That's the key. And our integral is just going to have u's in it. There's going to be times when you have to take that u substitution equation and solve it for the variable. That happens sometimes. So what you would end up with then is you would end up with this integral. Okay, that x is going to change into u plus 2. The x minus 2 is going to change to u. The dx is going to change to du. So the idea is you can do substitutions in a variety of different ways, but as long as everything's accounted for, you're good. So I basically had 3 pieces. I had this, this, and this. All got replaced. All right, do you guys see what I was doing at all? Sometimes students do, sometimes they don't. Now, is this an integral that you could do? Yeah, you could break this up like this, and you could write this as u over u plus 2 over u times du. Okay, you can split that fraction up into 2 parts. Okay, well that would be 1, so that's going to be the integral of 1 plus 2 over u times du. Okay, now let's see if we can get this integral done then. Okay, all right, so what's the antiderivative of 1?
0.
U, not 0. If you're thinking 0, you're differentiating. If you take the derivative of u, you get 1, right? What's the antiderivative of 2 over u? ln, okay, 2 ln of u, 2 is a constant, then you got plus c like that, okay? Now what you got to do is the last step is always the same on these problems, is u is x minus 2, so everywhere you see a u in that antiderivative, you're going to have x minus 2 plus 2 ln x minus 2 plus c, so that is the answer to that antiderivative. That's a more complex one, okay? I like to introduce that in Calc 1. We don't do that on the final because we just a lot of times feel like students don't have enough time to absorb that. What do you think? Okay, now sometimes you have to take the u substitution and solve that equation for x. That happens occasionally, okay? All right, let's wrap up with just a couple other things here. And I think what I'm going to do on on this one, I haven't done a definite integral yet, so I'm going to go ahead and I need to finish up by giving you an example of a definite integral, okay? All right, so what I'm going to do on this one, first of all, is since we're learning U-substitution, I'm going to do this one by U-substitution, okay? So when I do this integral right here, what I'm going to set U equal to is probably this thing right here. All right, so let's write down U is equal to 4 minus x squared. Okay, so that's going to be our U. All right, tell me what du is. Negative 2x dx, right? Okay. What were we hoping it was going to be equal to? 2x dx. We're close, okay? That's no big deal. So what we can do is we can just get rid of that negative. See, that's really a negative 1. If you want to divide or multiply both sides by a negative, you can do that. So that's what I'm going to do is just multiply this side by a negative 1. And I'm going to multiply that side by a negative 1. So you have an equation, so you can do the same thing to both sides. So you have negative du is equal to 2x dx like that, okay? So I'm going to go ahead and we're going to get this integral put together now, okay? So the thing that I got highlighted in blue is going to become negative du. Okay, so I've got everything accounted for, so my integral is going to be u for that, and then 2x dx is times negative du. Okay, the negative is a constant, so it can come out of that integral like that, and then that's an easy integral to do. Okay, everybody with me on that? Okay, now watch carefully because this is new. The other thing that you want to do is you want to learn how to change the limits of integration. Okay, you don't have to do this, but you better learn how to do it because it's easier to do the problem this way, by the way. Okay, so here's what we do. First of all, our limits are 1, our upper limit is 1. Our lower limit is 0. Those things are going to change also. So what you do is you use your U-substitution equation to change those limits. So that U-substitution equation is 4 minus x squared. Okay? So what you do is you plug in those limits of integration into that U-substitution, and that will change the limits. So if I plug a 1 in there, that's 4 minus 1 squared is 3, which means the upper limit is no longer 1, it's a 3. And we plug in a 0. Okay, so 4 minus 0 is 4. That means the lower limit is 4. And it does not matter that those things are backwards. A lot of times students say, oh my God, the 4 is bigger than 3, it can't be there. Yes, it can. It doesn't make any difference. So what I've done is I've changed those limits of integration by that U equation. Does that make sense? And see, if you do that, the integral that I have right here is a super easy integral to do. Okay? Makes everything a lot easier. So let's finish this up then. So I'm going to have a negative. Now when I do the antiderivative, what's the antiderivative of u to the first? U to the second over 2. And then evaluate that from 4 to 3. Okay, like we learned today. Now that negative is a constant, just ignore it. That'll be as a part of your final answer. So we plug in 3. You always plug the upper limit in. So it's 3 squared over 2 minus, and then 4 squared over 2 like that. So that's going to be 9 over 2 minus 16 over 2. So that looks like that will be a negative of negative 7 over 2. So the answer to that problem is 7 over 2. Okay, what's different about that one is that was a definite integral with U-substitution. So I did want to get to at least doing one of those today. Okay, so we'll work on this just a little bit more next time. Mostly what we're going to do next time is wrap this up and review for the final. To finish this up. Okay, on that problem that I had you pick up, one thing that you want to do, I gave this at the end of the test. It's not as hard of a problem. It seems to students, oh, it's just too much work. What you do on this cone problem, you can work together with a partner and turn one thing in. But what I recommend you do is this video takes you through a similar problem with different numbers. And mostly it's stuff you've learned. I just would like to put this into a little bit bigger context. If you do need help or anything, like I'm in my office, of course, today, and then I think tomorrow I'll be in like about 9:30 to about 12:30. So if you happen to be around the campus and you want a little help on that, just come by. Okay? Because we're all done with our gateway test.
In high school, you went to parties? How are you so smart?
I don't know if you can take this. This was in my notebook. He never grabbed it out.
Oh, okay, yeah.
So, do you have any of the cone problem packets?
What's that?
Do you have the cone problem packets?
They're on D2L.
Okay.
So it just, you can see on there, you just click on the link. There's a video, and then you can click on this thing right here.
Okay.
It'll upload it.
Are you going to your office?
What's that?
Are you going to your office?
Yep.
Office hours?
Yep.
I'll stop by in
Okay.
15 minutes.
So Brad, did you hear what all the awards Brittany got last night?
What's that?
Brittany,